Hello and welcome to another video on derivatives. In this video, we are going to discuss about the product and the quotient rules. So in the last video, we discussed about the basic differentiation rules where we use the basic rules for differentiation. Now, if we have a product of two functions, how do we find the derivative of those functions? I mean, the product of those two functions. So for example, we have two functions, f of g and, f and g. So the derivative of the product of those functions is given by, so the derivative of f times the function g plus the function f times the derivative of function g. Okay, so just to remember this easily, I usually use this. So for example, we have the first and the second function. Okay, so that's the product of two functions. Now the derivative of this function is the first function times derivative of second plus second function times derivative of first. Again, if we switch them, it really doesn't matter because we have this plus sign. That means we can write this first and this next. It really doesn't matter. Okay, so I think saying this one, first function times the derivative of second plus second function times the derivative of first, just saying that is easy to remember. So let's look at this example here. So this is the first function, the one that we have here. So this is the first function and this is the second function. Okay, now the derivative of that product is, so the first function, we'll just copy the first function as it is. Again, if it does not matter if you switch the order. Okay, if you do the second function and then find the derivative of the first, it's totally fine. It really doesn't matter. So we'll copy the first function, then times the derivative of the second function, which is 2x, then plus the second function, which is x squared minus 1, times the derivative of the first function, which is 6x squared minus 2x. Now all we need to do is we'll just multiply this and then write the simplify the expression. Okay, so 2x cubed times 2x is 4x to the fourth. 2x times negative x squared is minus 2x cubed. Then 2x times 1 is 2x. Then x squared times 6x squared is plus 6x to the fourth. Then x squared times negative 2x is negative 2x cubed. And then negative 1 times 6x squared is minus x, 6x squared, then plus 2x. Now this gives us, so let's combine the like terms. So we have x to the fourth here and here. So that is 10x to the fourth. Then we have x cubed here and here, which is minus 4x cubed. And then we have x squared just here, so minus 6x squared. And then we have 2x plus 2x, which is 4x. So that is the derivative of that product. Now let's look at another example. Here the first function is x to the fourth and the second function is e to the x. So the derivative of this product is the first function, which is x to the fourth, times the derivative of second function, which is e to the x. So the derivative of e to the x is just e to the x, plus second function, which is e to the x, times the derivative of x to the fourth is 4x cubed. And then this is just x to the fourth, e to the x, plus 4x cubed, and I'll write e to the x right here. If you want, you can factor out, but we really don't have to because just factoring is not going to simplify anything. So we'll just leave it right there, okay? That was the product rule where we have the product of two functions. Now, if we have the quotient of two functions, or if we have two differentiable functions and we are dividing one function by the other, then this is the derivative. So it is the function in the bottom or the denominator times the derivative of the function in the numerator minus function in the numerator times the derivative of the function in the denominator divided by the function in the denominator is squared. Okay, so again, just the shortcut to remember this easily, this is what I usually do. So we have a function where we have the quotient, so derivative of, so let's say numerator over, so the function in the numerator, I'll just say numerator n, okay, and function in the bottom, I'll just say denominator d. So the derivative is denominator, so we start with d because d comes before n. So denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared. And one important thing here, the order matters because we have the negative sign. In the product rule, the order does not matter, but here the order matters. So we really have to be careful with that, okay? Now let's look at an example. So here this is the numerator and this is the denominator. So the derivative of this function is given by, so f prime of x equals, so denominator, which is x cubed minus 2 times the derivative of numerator, which is 5x to the fourth, minus numerator, which is x to the fifth plus 3 times derivative of the denominator, which is 3x squared. Everything divided by x cubed minus 2, the quantity squared. Okay, let's go ahead and multiply this and simplify. So when we multiply here, we get 5x to the 7th minus 10x to the 4th. And then when we multiply here, we get minus 3x to the 7th minus 9x squared divided by x cubed minus 2 squared. Now, let's go ahead and combine the like terms. So 5x to the 7th minus 3x to the 7th is 2x to the 7th. And then we have negative 10x to the 4th, which is minus 10x to the 4th. And then we have minus 9x squared. Everything divided by x cubed minus 2 squared. And then we'll just leave it here. We cannot simplify further. Now let's look at this second example here. Again, let's just use the quotient rule. So g prime of x equals the denominator, which is x cubed plus 6, times the derivative of the numerator, which is 2x plus 1, minus then the numerator, which is x squared plus x minus 2, times the derivative of the denominator, which is 3x squared, divided by x cubed plus 6 squared. Now, let's go ahead and multiply. So when we multiply these two, we get 2x to the fourth plus x cubed plus 12x plus 6. So when we FOIL here, okay? And then the second part is, sorry, and then the second part is, sorry, I messed up this. Just let's go back here. Ooh. Right here. Okay, sorry about that. This is technology, so sometimes we have some problem with the technology. So when we multiply here, we get minus 3x to the fourth minus 3x cubed plus 6x squared. So just be careful here, okay? So we have this negative sign here. We need to distribute that negative sign as well. So all the signs are changed. So positive becomes negative and negative becomes positive. So everything divided by x cubed plus 6 quantity squared. Now let's go ahead and combine the like terms. So if we look over here, we have x to the fourth here, okay, x to the fourth, and there's x to the fourth. So when we combine that, we get negative x to the fourth minus 2x cubed, when we combine x cubed with negative 3x cubed, and then we just have plus 6x squared, and then we have plus 12x, and then plus 6 divided by x cubed plus 6, the quantity squared. And then we cannot simplify further, so we'll just leave it right here. So that was the product and quotient rule. So here is a problem for you to try. So you can pause the video, do this problem, and then resume the video, and then check your work, okay? So we are going to do it now. So the first one is using the quotient rule. So the derivative of this function is f prime of x equals the denominator, which is x squared minus 1, times the derivative of numerator, which is just e to the x, because the derivative of e to the x is just e to the x, okay? Minus numerator times derivative of denominator, which is 2x, divided by x squared minus 1 squared. So now we can factor out e to the x from both the terms, and then we have x squared minus 1 minus 2x over x squared minus 1 squared. Or we can rewrite this as e to the x times x squared minus 2x minus 1 divided by x squared minus 1 squared. And that is the derivative. Now let's look at the second one. This is a quotient rule. Sorry, this is a product rule. So we have this first function and the second function. Okay. So g prime of x equals the first function, which is 4e to the x, times the derivative of second function. So we already know the derivative of square root of x is 1 over 2 square root of x, then plus, okay, plus the second function, which is the square root of x, times the derivative of the first function, which is just 4e to the x, because it's the constant times e to the x. Now what we can do here is we can factor out 4e to the x. So we have 1 plus 2 square root of x plus square root of x. Now we can make a common denominator and then we can simplify this. So for that we have to multiply this one by 2 square root of x times 2 square root of x. So that way we get 4e to the x times 1 plus 2x divided by 2 square root of x. And then we can just leave it right here. So here is the question where we are going to find the equation of the tangent line to this function at 2 comma 6, and then you can graph and see both the curve and the tangent line. I'm not going to do that here in the video. You can just put it in your calculator. Okay, so now let's go ahead and find the derivative of this function first. So f prime of x equals the denominator, which is x squared minus 3, times the numerator, which is the derivative of the numerator, which is 2x, okay, minus the numerator, which is x squared plus 2, times the derivative of denominator, which is 2x, divided by x squared minus 3, the quantity squared. Now if we simplify this, we get 2x cubed minus 6x minus 2x cubed minus 4x divided by x squared minus 3 squared. So 2x cubed minus 2x cubed is 0, so negative 6x minus 4x is negative 10x divided by x squared minus 3 squared. Okay, now that's the derivative. What we want is we want the slope of the tangent line. So the slope of the tangent line at x equals 2, because we are finding at this point. So the slope of the tangent line at x equals 2 is given by, so the slope of the tangent line, okay, m, is given by f prime of 2, which is negative 10 times 2 divided by 2 squared is 4 minus 3 squared. So the denominator is just 1, so the slope is negative 20. Now let's go ahead and find the equation of the tangent line. So we are going to use the point slope form of the equation. So y minus y1 equals m times x minus x1. So y minus y1 is 6 equals m is negative 20 times x minus x1 is 2. So this gives us y minus 6 equals negative 20x plus 40. Now if we add 6 on both sides, we get y equals negative 20x plus 46. And then this is the equation of the tangent line at 2 comma 6. Now you can go ahead and graph both the curve, the function, and the tangent line, and you can verify the tangent line should go through 2 comma 6. Okay. Now the next one is the derivative of e to the ax. Okay, so we know that the derivative of the function e to the x is just e to the x, but now when we have a constant here, that becomes, so derivative of e to the ax equals a, so the constant comes down, and still we have the constant over there, okay? So a times e to the ax. So this can be proved by using the product rule repeatedly, but we're not going to do the proof here, okay? So we'll just use it. Now let's go ahead and do the first problem here. So we have to use the product rule here because we have two functions, x and e to the negative 3x. So let's use the product rule here. So dy over dx equals the first function times the derivative of second plus second function times the derivative of first, which is just 1 because derivative of x is 1. Okay, now that equals, so here we can factor out e to the x out. So if we want, so if we factor out e to the, sorry, e to the negative 3x, if we do that, we get negative 3x plus 1 as the other factor, and we can just leave it right here. This one we have to use the quotient rule. So dy over dx equals denominator times the derivative of numerator is 3e to the 3x. Now minus numerator times the derivative of denominator is 2x divided by x squared squared. Okay. Now if we multiply this, we get 3x squared e to the 3x minus 2x e to the 3x over x to the fourth. Now if we factor out x from the numerator, we get 3x e to the 3x minus 2 e to the 3x divided by x to the fourth. So we can cancel one of the factor of x from here and then this x. So that gives us 3x e to the 3x minus 2 e to the 3x over x cubed. So this is the derivative of the given function. Now let's look at this final problem where we have the combination of quotient rule and the product rule, okay? So now here we have the quotient, so numerator and denominator. So the first thing that we are going to do here is to use the quotient rule. So I'm going to write it this way. So I'll write this one as dy over dx equals, so the denominator, which is x squared plus 3 times the derivative of the numerator. Let me write it this way because we have to use the product rule right here. So let me write it this way first and then we'll do the derivative. Okay, so 2x e to the x. So this is denominator times the derivative of numerator minus numerator, which is 2x e to the x, and then the derivative of the denominator, which is x squared plus 3. Now everything divided by x squared plus 3 squared. Now x squared plus 3, so here we really have to be careful because we have to use the product rule here, okay? So for this one, we have to use the product rule. We have the first function and second function. So it is first function times the derivative of second, which is e to the x, plus second function times derivative of first, which is just 2. So there's just this derivative here in purple, okay? And then we have minus 2x e to the x, then the derivative of this is 2x. Now from here, just from here, we can factor out, we can factor out 2e to the x from everything. So 2e to the x, if we factor that out from everything, then we have x squared plus 3 times x plus 1 here, and then minus, we factor out 2e to the x, so we have 2x squared. Okay, then, sorry, we missed the denominator here. So for this one, everything divided by x squared plus 3 squared, everything divided by x squared plus 3 squared. So don't forget the denominator. Now let's write 2e to the x times, so let's multiply here, okay? So x squared times x cubed, x squared times 1 is x squared, plus 3 times x is 3x, plus 3 times 1 is 3, minus 2x squared, and then everything divided by x squared plus 3 squared. Now we have 2e to the x, so this is x cubed. Then we have x squared minus 2x squared, that means minus x squared. Then we have 3x, so plus 3x plus 3 divided by x squared plus 3 squared, right here. So that is the derivative of that function. It is a little bit complicated because we have both product and quotient rule together. So we'll just do this much for this video. We'll come up with more videos. Next video would be on the derivative of trig functions. So I'll see you again in the next video.